here we go with DNS. Now, again, what I was saying is I did this lecture so that this will be used whether it's Linux or Windows. It's not going to be specific to either one, because DNS, the client end of it, is something that everybody's going to use. So this is it. This is DNS. Purpose. Computers do not understand words such as yahoo.com. We kind of anticipated that. DNS resolves names to IP addresses, or it can also do the opposite, called a reverse DNS. You can put in an IP address and it resolves to a name. Now that's, yeah, if you're looking for somebody, if you see an IP address hitting your firewall, you can turn it around. But the pointers aren't always offered. They're almost always going to have to be offered on a local network, because a lot of times if a computer sees an IP address and doesn't recognize it, it may sit there and time out for a minute. It'll punish you for not having a reverse DNS, pretty much. But what can be said right here is the basics of DNS are really simple. Oh yeah, you're just taking this. It's like my telephone. I can look for the name Steven and push a button and not have to remember the phone number. So it's the same sort of deal. DNS is like a lot of other things. The beginnings of it are real simple, but once you start getting into the guts of it, you're diving off a cliff into a lot of complexity. Provides information about a service or domain, like what is the IP of the mail server. If you send email to steven@abtech.edu, that's not a machine name. All that you have is abtech.edu. That's a domain. Steven is a user. So if you ask for the mail server, you're asking it of the domain. We'll get into that a little bit more. The DNS server can provide different kinds of information, and we'll look at the different records in a minute. How important is DNS? It's very important. The last time that I installed Active Directory in Windows, it gets to a point and it says, well, it's time to do something with DNS. If you want me to install it, we can do that. If you want to point me to some DNS, we can do that. But we're going to go one of these two routes, or we're going to stop right here. So that's how important it is to Windows. It's also important to, a local network. If you don't have it, you're going to be typing in IP addresses for websites, and even that screws up sometimes if it's a complicated sites. Multiple DNS servers should always be in use. Since we are networking students, you will always have at least 2 DNS servers in use, because failure is too big of a problem. DNS servers can be used 2 different ways. Question. 2 different ways you can use DNS. You can use it as a caching name server. Think of a server, the preferred DNS is what we'll call it, for this network, so that if user A sits down and types in www.cnn.com, it'll go to that server to try to resolve, and then that server is going to go and find it for you and then cache it. It's going to hold it in memory for some amount of time. And so that way when user 2 comes along and asks for it, boom, it's got it and can just return it. So that's handy for the local network, telling it's for the local network for all these multiple domains out in the world. Yes, it's called the preferred DNS. There should be multiples of them. Resolves IP for names requested by a local network. Yes, and it caches them. These queries are might not be considered authoritative. We need to talk about the term authoritative. If someone asks, how many kids does Stephen have? You could ask John, he probably knows. You could ask somebody else. You could ask Lewis, they probably know. Who is the authority on how many kids I have? I'm the only one. I am the start of authority for that piece of information. So you would have to go to the source. Some server is going to declare itself the SOA, the start of authority, for a particular domain. That would be an authoritative. Since this would be pulled out of cache, this might not be authoritative. Problem being, DNS IP mapping doesn't always stay the same. Case in point, years ago I had a Bell South connection that was dial-up or something, but my IP address changed a lot. So I used this service that would spit a message to my DNS and say, here's my IP, here's my IP, here's my IP, and do that continually. Sometimes my IP address would change every 5 minutes. I'd have a different IP. Just depend. Yeah, if I just wanted to use a domain name for my machine. So my IP changed a lot. So if it cached Stephen's website to a particular IP, in 30 minutes, it could be outdated information. and it wouldn't work. So in that case, you would really need an authoritative answer. It also can be configured as your authoritative name server, which that is your SOA, that is your start of authority. And it answers questions about your local domain. If I am stevensdomain.com, this server is being the authority. He says, I can tell you where the mail server is, and I can tell you what these machines are. It answers queries from local networks, and it also answers from remote networks that are looking for you as the start of authority. They can be considered authoritative. A single server can perform both jobs, but scope and visibility must be addressed. So if you have a DNS server, one of the things it has to do, like we're in a lab right now, we're in 208. So our DNS server has records for any machine that I'm pointing to. It's taken its MAC address, IP address, and it's going to map it to ball 208.05. And DNS needs that so that it can see it. So all these local records, the records for our file servers, the records for all the things locally, that's in there. But if that server is also performing the job of resolving authoritatively for our web server, for our email server that people would need from the outside, that's too much information. People don't need to know what the IP address is of each and every one of these machines. So visibility is a big issue. The first step in hacking is footprinting, going into a network and looking around to see what IP addresses and what machine names are there. Now, if you're a hacker, you can use some kind of ping sweep and look around and see what answers, and that's a little bit of work. If your DNS will cough up its entire record at one time, that's called a zone transfer. And talk about a gimme, just in case some of the machines were off or you didn't have time, here's the entire network, poof, and what I'm calling. So security is an issue. You want some things from the outside. You need maybe web server, maybe NS server, and then nothing else. A single server can still do all of it, but the newer DNSs deal with something called scope or visibility to see who can see what. Go ahead. The question was about virtualization, and would companies do this in two different virtual boxes? Now, what's silly is if you have one piece of hardware and run two DNS servers and two virtual machines on that same box. That's a little silly. But to solve this problem, if you had like a network and then you had a DMZ, a lot of times people would put a DNS server in the DMZ specifically just to answer this handful of records, and then inside the network in its own little branch there, you would have another DNS server that would resolve names locally. There's a song and dance with everything, every solution that you come up with. At that point, you've got two machines to administer, two machines to update, and there's other issues, but it's always a choice. So, all right. Master slave. Usually you just have one DNS server that is authoritative that can be updated. You don't want confusion between two servers. So usually your masters are updated and queried. Slaves a lot of times aren't updated. They receive their information through a zone transfer. Now that zone transfer is something that you would need to address security on, like just what I said a minute ago. If you can be a regular dude and take a zone transfer, that's your footprinting done in one fell swoop. You can't have your slaves queried by the local network or by some other network. You just say, I'm not receiving information, but I'll tell you what I've got. And sometimes you can do that for load balancing if one is really getting pounded, if you got really busy DNS servers. And a DNS server one server can be, that's what I'm saying right here, can be a master for 100 domains and be slave for another 100 if you had, for some reason, a bunch of domains. Think about the server where everybody and their brothers bought their own domain name. They've got on GoDaddy.com and bought something silly to name their website. So you could have a bunch. So one server could say, okay, I'm master for these, but I'm slave for these. So zone transfers can be partial or complete. The partial transfer, of course, is going to save you some bandwidth. Zone transfers are usually over TCP, where your normal is going to be over UDP. A good segue into my next slide. DNS uses UD port 53, therefore it's connectionless by design. Just a real quick, it's not building a connection, it's just asking a question. Hey, how about getting back to me about this? Port 53. and should make sense. DNS servers always have to have a static IP address because you have to refer to them by the IP address, because if you don't have a name server, you can't call it name server. There's nothing to resolve it unless you do it in the machine itself. Type of records that are stored in DNS. The A is the simple, just plain Jane, here's the name, here's the IP address. Mail would say, okay, I don't know what you call the machine or what its IP address, but give me the name and in turn the IP address of the machine that handles your mail or machines. Again, redundancy is important. Of the name server, if there are other name servers, again, there should always be redundancy. A CNAME, her common name, or it's also canonical name, is an alias for a host, so you don't have to type in some big long name to get you your SQL server. You can just type in SQL or something just for a shortcut. Pointers are used only in reverse DNSs, and they're a little bit different. All right, just a second. DNS is a hierarchy. Domain names are not case sensitive, even in case sensitive Linux. Some domains, Bind used to have a problem with dashes, so that kind of leads you toward being more simple with your domain names. Here's something that you may not know. Google's name is actually http://www.google.com. Similarly, CNN is www.cnn.com. Any URL that you've got in your head, at the end comes a dot. Now you may be thinking, I never put in a dot. Well, since the dot is at the end of all of them, your web browser lets you get away without it. I'm not actually going to bring up a web browser and put in something with a dot. Just trust me on it. The dot is always there. And the dot has to be there because DNS is a hierarchy, just in the way that it's organized. There's something that's got to be at the very top. Think about the file system. There's a root to the file system. There's a common point for everything to hang off of. It's the same sort of deal. So there's a dot there, but we never have paid much attention to it. DNS addresses all have that common point. Addresses go from most specific to least specific. Try to come up with some examples. How about a telephone number? You've got your area code. That's not specific. You've got an exchange. That's more specific. And then you have the number, and that's the most specific. That would be the opposite of what I'm talking about. How about a postal address? Stephen Marcus, this building, this address, in this state. You could go so far as to say in this country. I didn't throw zip code in there because it kind of throws my analogy off. But this would get it to the right country, then to the right state, then to the right address, building, then me. So this is the most specific, and this is the least specific. And that's the way that your address is going to run. So I'm giving you an example right here of www.computerscience@university.edu, and I threw my period in there. www is an actual machine name. Computer science, sometimes you have subdomains that will have their own DNSs under a big domain, and you can put them several levels deep if you want to. University would be the domain, and it's getting less and less specific. Finally, edu is your TLD, your top level domain. And we know these. We know com and edu and biz and gov and mil and all of those. Finally, you have the dot, which is the least specific, meaning it's somewhere on the internet in the DNS system. So if we draw it as a tree, there is your DNS root. Beneath that, you have your top level domains. And no, that's not all of them. There's a bunch. Beneath that, you would have your domains. That's what you buy at GoDaddy.com or whatever. You can have subdomains underneath that. For that matter, you can have subdomains under your subdomains if you want to go to that trouble. And then finally, you can have a host at several different levels. Let's do an example. If you do an NS lookup, and we'll get to that command in a minute, this is kind of like your basic Windows, Linux, works in both, DNS query. Client makes a recursive request. Here's your mouse. There's your client. He says NS lookup, and it goes to your preferred DNS, meaning recursive means this guy's going to do all the work. If the answer is cached, the result is simple. It goes, oh yeah, I know where that is, puh, and it spits the information right back. That's the purpose of caching. It speeds things up. If he doesn't, we're going to go some other place. Okay, this is the uncached DNS request. The client asks it something, and he goes, I don't know, let me go look. So the client asks the DNS queries for the root location. Now here's something I was going to hit just a minute ago. You can have static IP to name mapping on the local machine, and it always is searched first. Remember, in Linux, it's etc hosts. If you've been through the web server class, you'll remember Windows System 32 drivers etc hosts. That is always checked ahead of going out to find something. It's checked ahead of asking your preferred DNS. We'll probably hit that again in just a minute. But somewhere, there's got to be a listing of these root servers for this DNS to go out and fetch and to say, okay, somebody tell me where the root of this thing is. Give me an address because I got to ask them a question. So that's what it does. It's asking for the location. Who handles the edu? Now, obviously, this is going to be a group of servers someplace that the terrorists would just love to attack. But they're actually resilient enough that it's hard to attack. There's like a bunch of them, and we'll see here in just a second. But this guy just asked the root. He says, give me an IP address so that I can get to edu, and I'm going to work my way through this list. What it will use is a file called the root hints. And hints means pointing to that root of the file system. To find the root of the DNS, root hints has many addresses to access the DNS root. This is the same file that I talked about just a second ago. This is the hints. var named.root, and in Windows it's System32 DNS cache.dns. Now, in order to see this, you would have to have DNS installed on your Windows machine. Just a client's not going to have this. This is the server end. This information has to be there at install time because there's nobody for it to ask. Luckily, the list has been pretty static, and it's not that big of a deal. Here's a tiny section of what it looks like, and A, B, C, D. You can tell it's kind of grouped. I'm not going to go too deep into it, but you can see there's a big list of IP addresses for it to choose from, according to some geography or something, for it to go out and find the root of the internet. Okay, once it's got that and it knows who to talk to get the edu, it sends a message to edu and says, hey, can you tell me who handles who's the start of authority for university? It asks this guy returns and says, here's your IP address to go ask. And at that point, it works its way down. It goes to university, and it says, okay, the next level down is this CSI subdomain. Can you give me an IP address for that? It does it. That's called a delegation, a DNS delegation. So the CSI has been delegated by university. This could very well be both domains handled by a single machine at some point or another. But if it's not, it'd be delegated. Finally, this guy queries the CSCI, which is the authoritative name server for this domain, csiuniversity.edu, and he gets an IP address for www. Once the DNS server's got that, he caches it, and he can finally spit it back to the client. So it kind of makes sense the way it goes through it. To see how DNS is configured on the client side, in Windows, it's ipconfig/all. And there's what you get. You get a listing of your primary and whatever secondary DNS servers you have. That's your preferred DNSs. So if 14 is dead, it can't get a ping from it. It waits for a second for it to come back. It doesn't come back. It just goes on to the next one. And then you have the rest of your information in there you've probably seen before. How is it retrieved? It's either retrieved through through DHCP as the machine boots, or it can be specified manually, just like you specify an IP address. Linux, it's in etcresolve.conf. There's you an example, and it just says name server and lists them. And in the same way, it can be picked up through DHCP, or you can configure it manually. To give you a look at Linux configuration, in Windows, I didn't put this into an actual slide, but there's an order of things that are searched. When you type in NS Lookup chicken@chicken.com. The first thing the machine does is it says, well, am I chicken@chicken.com? Yes or no. If it doesn't, a Windows box is going to go to that System32 drivers etc hosts file and look through there. That's going to be the quickest. If it can't find it there, that's when it's handed off to the preferred DNS and we go through the ritual that you just saw. Linux, you can configure it a little bit more. You've got a file called host.conf, and it says order hosts, bind. That's the only way I've seen it. The way this works is it looks in that etc hosts file first, and then it uses bind, name D, to go out and resolve stuff. If for some reason you didn't want your etc hosts file consulted, you could leave that out. If you didn't want to go to bind, you could leave that out, and then all you would have is your etc hosts file. You don't tweak that too often. Your etc hosts file, this is just what this is representing. This is just local mapping. Like this machine right here, we don't have it in our DNS, or if there's some machine that I just named and I know it's not in our DNS, I can throw it into etc hosts and use it as if it was an address. Yeah, you could type in ping Atlantis, and at that point it would work. And that's what we do in the web server class. Another thing that's done is the Network Nanny software would take, instead of where I've got Atlantis, it would take www.playboy and penthouse and smut.com and point them all to 127.0.0.1. And you just have to maintain that list, and that would be a very rudimentary way of stopping, unwanted stuff. You could also do that with your pop-up ads and spam and CRUD generators out on the internet. You could block all of those. Some viruses would drop in and modify this file and put in McAfee and Semantic and all the places where you would go to look for help. I've seen that happen, and point them to an IP address of another server with more viruses. So that's the way that works. Resolve.conf. This line right here, since this is a Linux class, I'll go ahead and tell you. If I type in ping chicken and enter, chicken is not an FQDN, a fully qualified domain name. A fully qualified domain name contains everything with top level domain, everything except the dot at the end. This is the local network. That's what it's saying. It's saying if you don't type in anything after the name, it's going to assume when I typed in ping chicken, it's going to say, oh, he meant chicken.internal.nettechnet.org. And that would give it a fully qualified domain name. And then there are your name servers listed 1, 2. You can list more than 2. You can list a bunch if you want to. Client commands. DNS Lookup. I throw that in there first because it works the same way in Linux and in Windows. You can do there's an example, and there's an example of the reverse DNS Lookup. Host and dig are in Linux. I've never seen them in Windows. They're similar. I'm going to show host. Dig is kind of like the bigger, badder, newer command, but host is going to be just fine. DNS Lookup is a little bit less powerful, but it's real common and easy to use. DNS Lookup www.ebtech.edu, and it spits back IP address. And well, let's look up here. See what I'm pointing at. There's my server. What's the #53? It hit port 53, so that's telling you what port it was even on. Non-authoritative answer. It says that because the result was cached, and it gives me an IP address. Here it is. There's a small chance it could have changed, in the amount of time in the last hour since I did this or whatever. But here's what it is. It's probably good enough. Here's something else you can do. This is using the host command. I did host www.abtech.edu, but out here as a third argument, I put in the IP address of another DNS server. I said, don't look at resolve.conf, look at this, and go and ask this DNS server what he has an address for, and it could be something completely off the wall like that if it had something for it. And it's different DNS specified. There's just your basic host, abtech.edu. If you don't specify anything, it returns your A record. Remember, the A record is just a plain Jane www mapped to an IP address, and there's what it is. Can a host be mapped to more than one IP address? Let me give you an example. I'm going to hop out of this real quick. Okay, I found what I wanted to do. I'm going to do a DNS lookup of www.google.com. And I picked Google because it's huge. How many people hit Google a day? There are people that have scripts and have been limited to 1,000 requests a day. So Google is used for a lot. It gets pounded. There's my point. Address 1, 2, 3, 4, 5, 6. 6 different addresses for google.com. And there's the reason. It's load balancing. If you hit one of them and it doesn't answer, go to the next one. So a lot of big websites will do this. DNS lookup, www.abtech.edu. We've just got one. And again, these are non-authoritative answers. I wonder if I could come up with something that wasn't a non-authoritative answer. Some website that's not been cached. Okay. Okay, I was digging too much of a hole with that. If you actually went and asked the server itself, anytime you ask your preferred DNS, it's going to be non-authoritative. You have to actually ask the service. Okay, host, you can put in a -T. I said type MX. I said give me the MX record for abtech.edu. And again, I don't have anything out here, so I'm actually asking my preferred DNS. And it says mail is being handled by 2 different servers. This value right here is going to be your preference. Hit one over the other. If they both work, pick the lower number. Or higher number. I forget which it is. But anyway, it gives you multiple mail servers just for redundancy. And that was with the -T and then the type of record. And you can dig that out through the man page. Notice that I didn't give it a machine name. That's not www.abtech.edu because the web server is not going to handle the mail. That's something easy to forget and slip up and do. Type NS. What are your name servers for abtech.edu? NS1 and NS2.abtech.edu. And then I could spin around and say, okay, host ns1.abtech.edu and pull out its IP address. But since DNS does that for you, you don't have to. Host-A. A would give you everything. Gives additional information. Notice it gives your answer, the IP address that is the answer of your actual request. It gave you authoritative name servers, a little bit of extra information, and it also tells which DNS server it pulled it from and how long it took it. So there's a good little troubleshooting command. Yeah. Basics of DNS are simple. But they can get more complicated, and we'll see when we start digging into it. Name servers are an integral part of networks. They've got to be, unless you want to start remembering IP addresses for everything. I can remember probably half a dozen IP addresses. I can't imagine it's much more than that. Boom. And that's it. Okay, we had a good question. The question was, what if you have a record cached in your caching name server, and then the IP address changes? It happens. Google probably is not a good example. Google is going to pay a lot of money to keep their IP addresses because they're very, very important. But if Steven's web server at home, as long as I got a static IP address, it doesn't change too often, I'm okay with it. But if it does change, your record's screwed up. It's going to point to someplace out into the world. Could even be somebody else. These fields right here give you the timeout. The record itself will say, okay, here this is, and here's how long it's good for. After this number of seconds, then you need to go back and fetch another one because your information's probably bad. Alrighty. Okay, I chased a rabbit there for a minute that included me booting up a Linux machine. So the question was, what is the difference between an authoritative answer and a non-authoritative answer? So this works if I do it right. NS lookup, I'll eventually get it typed in, www.espn.com. And I get this big spiel here about here it is, but it's a non-authoritative answer because I didn't ask espn.com. I asked our web server or our DNS server, and the DNS server said, yeah, I hit it 30 seconds ago. Here it is. Now, what I can do is do host. I have never typed that in right. Type NS. I'm going to get the NS record for espn.com. Now I didn't say www.espn.com because there's not a mail record for www. It doesn't take mail. espn.com takes mail. So their servers are DNS1, DNS2, and I'm going to say host DNS1.espn.com, and it returns this IP address. This IP address is the IP for the authoritative name server for espn.com. Did I say that right? I think so. So now when I say NS Lookup, and I'm swapping back and forth between commands, I liked NS Lookup because it told me whether it was authoritative or not. I used host because I could throw it a type and knew how to do that. Probably both of these commands, if I went through the man pages, I could do it all with either command, but just to make things simple, I'm going to finally say NS Lookup www.espn.com, and then give it this IP address at the end. We saw this in the slides showing host would do this. Well, NS Lookup will do it too. Just cut and paste. So server, here's the server I am looking for. Let's do a clear screen. I'm going to do that command and get a non-authoritative answer. Then I'm going to do this command and get the authoritative answer. So in this one, the server I asked was 192.168.254.14. That's us. That's local. Has to be. That is a 1918 address. That's a local address. This one, even though it kind of looks like it, that is a legitimate IP address out on the internet, and I asked their start of authority about it, and notice this message that is up here isn't down here because I asked the start of authority directly, and that is my authoritative answer because I asked the authority. Alright. Maybe that'll be the end of it. Maybe I won't tack any more on. They're into this. Oops, I started